In today's class we will see about series and parallel combination of resistors. First we will take series combination of resistors. Series combination of resistors. Let us consider three resistors connected in series, and let us name them as R1, R2 and R3. Consider three resistors connected in series. And these resistors are connected, the series combination is connected to a battery. Let us say the battery voltage is V and name of resistors are R1, R2, R3. The current through each resistor in series combination is same, I. And let the voltage drops across these resistors are V1, V2 and V3. V1 is the voltage drop across R1, V2 is the voltage drop across R2 and V3 is the voltage across R3. So remember, when circuit elements are connected in series, the current through each element is same. So here the element is only resistor. So the first point to remember is the current through each resistor is same and it is equal to the current flowing through the circuit. Current through each resistor is same and is equal to the net current flowing through the combination. So in our circuit the total current is I, we have named it as I. So the current through R1, R2, R3 etc. are all equal and it is equal to I. And in series combination, sum of potential differences across individual resistors of the series combination is equal to the net potential difference applied across the combination. So net potential applied across the combination V is equal to V1 plus V2 plus V3. V1 plus V2 plus V3, where V1 is voltage drop across R1, that is I into R1. Similarly V2 is the voltage drop across R2 and V3 is I into R3. So these are all from Ohm's law. Now let R is the net resistance of the combination. If R is the net resistance of the combination, let R is the net resistance of the combination. So then we can write the total voltage V is equal to I into R. If R is the net resistance, then the net applied voltage will be is equal to I into R. So now substitute these values in this equation. So let us take this equation as A, B, and list this equation is 1. So substitute A and B in equation 1. We get substitute equation A and B and in equation 1. So there we have V that is I into R. I into R is equal to I into R1 plus I into R2 plus I into R3, or I into, you can take I outside, I into R is equal to I into R1 plus R2 plus R3. So from this we get R is equal to R1 plus R2 plus R3. So the net resistance in series combination is given by the sum of the individual resistances. R is R1 plus R2 plus R3. Now let us see the parallel combination of resistors. Parallel combination of resistors. Now again here let us consider three resistors R1, R2, R3 which are connected in parallel. R1, R2, R3. Unless this combination is connected to a battery of voltage V. Now the total current through the circuit is I, and the individual currents are I1, I2, I3. Consider three resistors connected in parallel, and let a battery is connected to this combination. The total current through the circuit is I, and the current through individual resistors are different. They are I1, I2, I3. Now because resistors are connected in parallel, the potential difference across each resistor is same, and it is equal to V. In series current is same, in parallel combination the potential difference is same. So first point is potential difference across each resistors is same and is equal to the net potential difference. We applied across the combination. And the total current through the circuit I, net current I is equal to I1 plus I2 plus I3. Net current I is equal to I1 plus I2 plus I3. Now let R is the net resistance of the circuit. And we have here, we can write I1 is V by R1. So here we can write I1 is V by R1. Similarly, I2 is V by R2. And I3 is V by R3. So let R is the net resistance. Let R as the net resistance of the combination. So then we can write I is V by R. So combining all these equations, finally we can write I, that is V by R. V by R is equal to V by R1 plus V by R2 plus V by R3. Or we will get cancel. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So the total resistance in parallel combination as 1 by R is 1 by R1 plus 1 by R2 plus 1 by R3.